We will learn how to detect a cycle in a linked list. So first thing, we will detect the cycle. If a cycle is present in the linked list, then we will try to find which is the node the last node is pointing to, which is the internal node the last node is pointing to. So that is the joining point. Okay, so the two thing we'll try to find out. And this algorithm is based on Floyd cycle detection algorithm. So let's go ahead and code it. So to create a linked list, we need a node. That's the linked list node. So let's make it static. It has a data, it has a next pointer. Let's create a constructor. Let's initialize next as null. Okay, so let's go ahead and create the first node of the linked list. So let's create the linked list by creating some more nodes. So okay, let's have a setter. So okay, so let's return the next node so that it will be easy for us to create new node and assign the next node basically. So set next. So now we are creating a new node and assigning the new node as the next node of the first node. Dot set next, again new node, which is 3. So meaning like 3 is the next node of 2. So let's create some more pointer, some more node. 4, 5, 6, 7 and 8. So now our linked list is created. Now let's create a loop. Now this doesn't have any loop. Let's create a loop, meaning the last node is actually pointing to one of the internal node, which is maybe, let's take the third node. Okay, so next dot next. Okay, now so now 8 is actually pointing to third node, which is 3. Okay, so now let's go ahead and code how to detect a loop. So let's pass the root, create the method. Okay, so now since we are following the Floyd loop detection algorithm, so here we have two pointers basically. One is a slow pointer, another is a first pointer. Let's initialize them both as the first node, which is root. So here what we'll do is we'll move the first pointer as 2 steps at a time and the slow pointer 1 step at a time. So if there is a cycle, they will eventually meet at some point. But if there is no cycle, they will actually end up having null, because they will be eventually reach the last node, which will be null basically. So unless they are not null, slow is not null and fast is not null, let's move them. Like I told, slow will move 1 step and fast will move 2 steps at a time. Now once they are moved, let's check if they're actually meeting or not at the same point. If they're meeting, then there is definitely loop. So let's print, okay, there is a loop, cycle found. So if cycle found, then we need to check which is the basically, then we need to see what is the joining point basically, which is the internal node where the last node is actually pointing to. Okay, so for that, like as you know, like according to the Floyd cycle detection algorithm, to find the joining point, so one is meeting point, second is the joining point. Meeting point means where they will meet, so that is the meeting point. So here if they're equal, so this is the meeting point. Once meeting point is found, we need to find the joining point, which is where the internal node that the last node is pointing to. So for that we need to basically start again one from the root, again from the meeting point. So right now slow and fast both are at the meeting point. So let's update fast as a starting point and slow is already at the meeting point. So now let's move them one step ahead at a time, so till they meet. So here till slow is not equal to fast, then we need to keep moving, just slow equal to one step at a time, fast equal to next. Okay, now once they come out of the loop means they are actually equal. So now we can safely tell that okay, they are at the joining point, which is the joining point found fast dot data. So this is the joining point, but so this is the else case, and once we found the joining point, then we need to return. If this doesn't happen here, if we reach here, that means actually slow and fast, either of them actually reached the end and there is no loop found. So we need to tell okay, no loop found. That's it. So let's run it. Cool. So this is the joining point found at 3. Since 8 is pointing to 3, so 8 3 is the joining point. So let's try another test case. There is no joining, there is no basically cycle here because 8 is actually the next of 8 is null. So let's see what is the answer. No loop found. Okay, that's it. This is all for today. Thank you.